In 1912, German geologist Alfred Wegener postulated that during late Triassic period, about 250 to 200 million years ago, a supercontinent which he called Pangaea existed, and that the parts started moving away from each other. He pointed to the similarities in the rock stratas of Americas and Africa as the evidence of his hypothesis. His ideas received support in the beginning of 1960s due to more understanding of plate tectonics and seafloor spreading. New theories suggest that about 190 million years ago, America and Africa started to separate, which gave rise to mid-Atlantic range. Subsequent tectonic movements brought the both continents to their present positions. Theory that the Earth's lithosphere, which consists of crust and upper portion of mantle, is divided into about 12 large plates and several small ones that float on and travel independently over the asthenosphere. The theory revolutionized the geological sciences in 1960s by combining the earlier idea of continental drift and new concept of seafloor spreading into the coherent whole. Each plate consists of rigid rock created by upwelling magma at oceanic ridges where plates diverge. Where two plates converge, a subduction zone forms in which one plate is forced under the another and into the Earth's mantle. The majority of earthquakes, volcanoes on the Earth's surface occur along the margins of tectonic plates. The interior of a plate moves as a rigid body with only minor flexing, few earthquakes, and relatively little volcanic activity. In essence, plate tectonic theory is elegantly simple. Earth's surface layer, 50 to 100 km thick or 30 to 60 miles thick, is rigid and is composed of set of large and small plates. Together, these plates constitute the lithosphere. The Greek word lithos means rock. The lithosphere rests on and slides over an underlying partially molten, thus weak but generally denser layer of plastic partially molten rock known as asthenosphere. From Greek asthenos meaning weak, plate movement is possible because the lithosphere and asthenosphere boundary is a zone of detachment. As the lithospheric plate moves across the Earth's surface, driven by forces as yet not fully understood, they interact along their boundaries, diverging, converging, or slipping past each other. While the interior of the plates are presumed to remain essentially undeformed, plate boundaries are the sites of many of the principal processes that shape the terrestrial surface, including earthquake, volcanic activity, and orogeny. It means the formation of mountain ranges. The process of plate tectonics may be driven by convection in Earth's mantle, the pull of heavy old pieces of crust into the mantle, or some combination of both. Crust is broadly divided into continental crust and oceanic crust. Continental crust, the outermost layer of Earth's lithosphere that makes up the planet's continents and continental shelves and is formed near the subduction zone at plate boundaries between continental and oceanic plates. The continental crust forms nearly all of the Earth's land surface. Oceanic crust, the outermost layer of Earth's lithosphere that is found under the ocean and formed at the spreading center on oceanic ridges, which occur at divergent plate boundaries. Ocean crust is about 6 km or 4 miles thick. It is composed of several layers, not including the overlaying sediment. The topmost layer, about 500 meters or 1650 feet thick, includes lavas made of basalt, a type of rock consisting largely of plagioclase and pyroxene. Oceanic crust differs from continental crust in several ways. It is thinner, denser, younger, and of different chemical composition. Like continental crust, however, oceanic crust is destructed in subduction zones. For more about Earth and its layer, visit our video on Earth and its layers. Link is given in the description. A continent is a large continuous mass of land conventionally regarded as a collective region. There are 7 continents: Asia, Africa, North America, South America, Antarctica, Europe, and Australia. Sometimes Europe and Asia are considered one continent called Eurasia. Continents loosely correlate with the position of tectonic plates. The continents are not distributed evenly over the surface of globe. If a hemisphere map centered in northwestern Europe is drawn, most of the world's land area can be seen to lie within that hemisphere. More than two-thirds of Earth's land surface lies north of the equator, and all the continents except Antarctica are wedge-shaped, wider in the north than they are in the south. The distribution of continental platforms and ocean bases on the surface of globe and distribution of major landform features have long been among most intriguing problems for scientific investigation and theorizing. Among many hypotheses that have been offered as explanation are 1. The tetrahedral or four-phase theory, in which a cooling Earth assumes the shape of a tetrahedron by spherical collapse. Second one is the accretion theory that states younger rocks attached to older shields areas become buckled to form landforms. Third is the continental drift theory, which tells that an ancient floating continent drifted apart. And the fourth is the convection current theory, which states that the convection currents in Earth's interior drag the crust to cause folding and mountain making. Geological and seismological evidence accumulated in 20th century indicate that the continental platform do float on the crust of heavier material that forms a layer completely enveloping the Earth. Each continent has one of the so-called shield areas that formed 2 billion to 4 billion years ago and is the core of continent to which the remainder has been added. Even the rocks of extremely old shield areas are older in center and younger towards the margins, indicated that this process of accumulation started early. In North America, the whole northeast quarter of the continent, called Canadian or Laurentian Shield, is characterized by ancient rocks of what might be called the original continent. In Europe, the shield area underlies the eastern Scandinavian peninsula and Finland. The Guinea highlands of South America are the core of the continent. Much of the eastern Siberia is underlined by ancient rock, as were Western Australia and Southern Africa. Continental drift, large-scale movement of continent over the course of geological time. The first complete theory of continental drift was proposed in 1912 by Alfred Wegener, who postulated that a single supercontinent, which he called Pangaea, fragmented late in the Triassic period, approximately 250 to 200 million years ago, and that the parts began to move away from one another. He pointed to the similarity in the rock stratas in Americas and Africas as evidence to support his hypothesis. Wegener's ideas received support from the concept of seafloor spreading and plate tectonics beginning in 1960s. The modern theory states that the Americas were joined with Europe and Africa until 190 million years ago, when they split apart along with what's now mid-Atlantic ridge. Subsequent tectonic plate movements took this continent to their present positions. The continent accretion theory is a 19th century geological theory that suggests that the continents have always been stationary, with the gradual addition of new material around the central nucleus. Another theory called continental assimilation theory suggests that the ocean accumulate denser elements then subside to form basins. The growth of continents might have occurred through geological time by addition of new continental material around the original nucleus, mainly through the process of geosynclical sedimentation and orogeny. The heat in the asthenosphere creates convection currents that make tectonic plates move a few centimeters yearly, and the process of moving slowly continues, leading to the continental accretion.